So I want you to find the area of these two figures for me. For the area over here, this is a square, 9 by 9. What's its area going to be? 81 inches squared, right? How about over here, 9 by 15? 135 inches squared. Now I want to compare those. First of all, what's the same between those two figures? The height is the same. The difference is the length. So when we change the length, we've got 15 over 9 equals 135 over 81. Is that ratio true? If I cross multiply, do I get the same amount? I get 1215 going in both directions. So that ratio of lengths, as long as I'm only changing one dimensions, that ratio of areas is equal to that ratio of that change in lengths. Remember last semester we looked at what happens if you change both lengths? If I went from 3 by 3 to 5 by 5, what's the area of the 3 by 3? 9 square feet. How about the 5 by 5? 25 square feet. The ratio there is not 3 to 5. The length is 3 to 5. What do I have to do to that to get the ratio of areas? Square it. 3 squared is 9. 5 squared is 25. That is our ratio of areas, 9 to 25. So if I'm changing both dimensions, I have to square that ratio of lengths. But when I'm only changing one dimension, the ratio of areas is just the ratio of that single dimension I changed. For example, find the area of a circle. I'm going to draw my radius a little bit different. With a radius of 8 inches. Tell me what to do. .14 times 8 squared. Pi times radius squared, which is what? 200.96 inches squared. What if we make this an oval? This length is still 8 inches. But now this length is stretched out to 13 inches. How many directions have we stretched it in? Only one direction. This thing's acting up today. So our area here, I'm going to take that 200 0.96, I'm going to multiply it by that ratio. I stretch that 8 into 13. So 200.96 times 13 divided by 8. 326.56. That's square feet. Is that the area of that oval? It actually is. The area of an oval, if this is A and this is B, A is what they call the semi-minor axis. It's half of the narrowest spot. B is what's called the semi-major axis. It's half of the widest spot. Area of an oval is pi times A times B. If I did that, 3.14 times 8 times 13, it will give you that 326. .56. Yeah, you use the pi button, it'll give you 72. Yeah. So why is this important to you? Well, yes. But much of what you guys are going to do is going to be on a sloped surface, isn't it? Talking about roofing, of course. There's something called a slope correction factor. This, if they keep going, I'll go up there and yell at them in a little bit. They're just moving. There's a storeroom up there for the conference. They're moving chairs and tables in and out right now. Let's say that this is a 612 slope. The slope correction factor is found. Wait, this is pissing me off. So we look at this triangle here, where the rise is 6 and the run is 12. How do we find the hypotenuse here? You got it, square root of 6 squared plus 12 squared. Gives us 13.416, right? The slope correction factor then is the hypotenuse over the horizontal side. 13.416 divided by 12, which gives us 1.118. What is that slope correction factor good for? Well, let's say that this here is 32 feet across. And let's say that this is on a roof. It is, oh, that's, you guys get the picture. That this roof is 48 feet, right? Now I want to find the area of that roof. Well, the area of the base of this is 32 by 48. That'd be the area of the floor, right? Underneath it. 32 times 48 is 1536 square feet. The area of the roof is just going to be that floor area times that slope correction factor. 1717.25. Let's check that and see to make sure that's what we come up with. Normally to find that area, I would take, to find the slope here, which would be the square root of, this is going to be 16 feet of run. What's my rise? It comes out to be 8 feet. You got it. So the square root of 8 squared plus 16 squared, right? Gives us 17.888, 17.889 feet. Multiply that by 2, gives you the distance around. And then times that 48 depth will give you the area of the roof. And note, we get the same number, 1717.3. We had 1717.25. Let's just round off here. So if I have a house that's 36 feet by 54 feet, and the roof is an 812 roof, find the area of that roof using a slope correction factor. We need to find the slope correction factor. It's an 812 slope. We need to start by finding that hypotenuse. How are we going to find it? Square root of 8 squared times, or plus 12 squared, gives us 1442. 14.422. We're going to divide that by 12 to get our correction factor. 1.202. So now we find the area of the floor. 54 times 36. 1944 times that slope correction factor. 23, 36, 69. Why is the slope correction factor an important concept? Well, when you're looking at loading in a building, not the type of loading Mason was just discussing. So let's say your floor area, let's say we've got a 32-foot span here on our floor. And we're using floor trusses so we can clear span the 32 feet. Let's say your floor area is weighted at 65 pounds per square foot. The roof above it, yes, I know my walls look kind of stubby, but I'm running out of room here. The roof above it is going, if it's going to have the same loading, is actually going to experience more per square foot when we adjust it. Let me show you what I mean. Let's say that we're looking at that roof and we figure what's going to sit on that roof. We're going to lay the roof flat here. This is the rafter. What's going to sit on top of that roof? What's the first thing that goes on the rafter? Sheathing. Anybody know the weight of sheathing? It's actually less than that. I say it's 35 pounds per 100 feet, 100 square feet. So a single sheet's only like 13 or 14 pounds. Yeah. Usually they figure 3.5 pounds per square foot for sheeting. Yes. Did I say plywood? Sheathing. Okay. So shingles, or what? Actually, what goes on above that? Tar paper goes next. Tar paper usually goes about, well, what pound do you use? 15, 25? 25 is 0.25 pounds per square foot. I don't know why I put square inches down here. It should be square foot. And then, of course, on top of that is shingles, right? We're assuming it's steep enough you don't need the ice and water. Anything over a 412 slope, you don't need the ice and water, right? Shingles, what's your weight per square for shingles? Usually it's 100 pounds per square. What's that? They usually go about 2 pounds per square foot for shingles. Why do they go 2 pounds per square foot? Now up to 2 layers. Yes, they actually are. Okay, I gotta look it up. Let's do this. We'll look. So yes, the OSB is actually 1 1/4. And the shingles are actually 3 pounds each, so we go 6 pounds usually for them. So for a square foot, that's 7.5 pounds per square foot. But now the way we analyze a roof is not per square foot of the surface, it's per horizontal square foot. So if this is 32 feet across here, we consider that to only be 32 feet of roof, even though it's sloped. So a foot of that roof is actually longer than a foot if we take it up the surface. Does that make sense? So we have to use that correction factor. So let's say it's still that 812 slope. We just had that correction factor up here of 1.202. So that's 7.5 pounds per square foot multiplied by 1.202. It actually is 9 pounds per square foot of materials. So the steeper that slope gets, the more you have to correct the weight of the building materials. If that makes any sense. So we have a 40-foot roof with a 10-12 slope. Figure building materials are 7.5 pounds per square foot. If this roof is, if this roof is 60 feet long, calculate the weight of the building materials on that roof. I'll give you guys a minute to find the weight of the building materials. This one. So we've got the slope correction factor is going to be what? Divided by 12, you're right. So we get 1.302. Is our slope correction factor? So then the area of this roof is 40 by 60, or area of the floor would be what? 40 by 60. My pen still sucks. 2,400 times the 7.5 pounds per square foot, right? Which is going to be 18,000 pounds. And then times that slope correction factor, 1.302, 23,000. So it does add 5,000 pounds by using that slope correction factor. No, it really doesn't. You can multiply the area by the slope correction. You're 6 off. You found the slope of the roof and used that. Yeah. And that's one way to do it. But they actually produce little books, little cheat books for contract. I know DeWalt publishes one. Your little speed square has a little book that comes with it. It's got a cheater book in it that has all the slope correction factors figured into it. Now, the other thing is, like, if you're measuring up the roof of a house, so let's say you've got this house that is 36 foot, right? Has overhangs on it of 2 feet. And let's call this here 42 feet. Let's give this a 1412 slope. What you can actually do is you can just measure up the base of the house. If you know the slope and you can estimate the overhangs. So what I would do is I would look at this and say, okay, the overhangs are 2 feet. So I'm going to call that 40 feet in that direction. Let's say there's 1 foot lookouts here. You guys know what that symbol means with a circle with an X in it? It's not lookouts, that just means it's coming towards you. It's a dimension coming towards you. So that just means there's 1 foot sticking out towards you there. So that means this becomes 44, right? 42 plus 1 on each end, which gives us a total of 1,760 square feet. For the slope, like that 1412 slope, have you guys ever looked at how to estimate a slope from the ground? Yeah. Use your speed square, actually. You can hold a level. A lot of times you have to have somebody helping you to make sure that level stays level. And you set your speed square on the level and sight up your speed square. Here, I'll draw it bigger for you. So here's your level. My computer's acting like a... So you have someone help you to make sure that bubble stays in the center of the level. Then you set your speed square on here like this, and you just you sight up your speed square until that lines up with the roof of the house. And then this will actually tell you what that slope is. It actually is marked on your speed square what the slope is. Because it has all your angle cuts for your plumb cuts and everything on there. So let's say we've sighted it, and that's how we got the 1412 slope. So that 1412 slope, we find that correction factor. Let's try that again. So square root, that's 18.439 divided by 12 is a slope correction factor of 1.537. So we just multiply that by the 1760. So the total area of that roof is 2704.4. So there, from the ground, without having to go up on that roof, you've got a pretty accurate estimate of that roof. Does that make sense? If we had a level of a speed square here and a little roof we could go out and measure, we'd go out and we'd use that to predict we'd actually measure a building, but you got the little garage out there, that one's kind of crappy. What's that? I know I got the level and speed square, but I was trying to think of a good building to estimate quick. Go burn your house down. So what we came up with out there was, because it's just a conventional frame, it's not a truss. So they just built one side of it to a height and ran rafters. So 12 by 19 is 12 by 18.7 or something like that. We'll call it 12 by 19 for a waste factor. 12 by 19 is 221 square feet. Is that right? $250.807. Is that what Mason's coming up with? So we've got the 5.5 and 12 slope. So we're going to find this here. Second square root, 5.5 squared plus 12 squared. 13.200 divided by 12. 1.1. So times 1.1 is our slope correction factor. And yes, 243 is what I get, 0.1 square feet. You had 250.8? Oh, yep, I screwed that up. You're right, 228. 250.8 is correct. That looks right. Thank you. What do you guys think? Okay. I think we're going to let you out of here for the day. No new homework.